In this value network optimization, we'll break them down into three parts. First, we'll look into the supply chain network to see how we can model your unique supply chain into the system. Then, we'll look into how we can derive value from the digitalized supply chain. And finally, we will try to understand how optimization technology can be utilized to maximize the value from this digitalized supply chain. We have prepared three scenarios today for our demonstration, mainly focused on the planning and scheduling, utilizing the digitalized supply chain. So first will be the long-term scenario-based decision making. Then we'll go into the midterm planning, where we focus on the master schedule, in this case more on the logistics side. And finally, we'll go into the shop floor level in a more detailed granularity to look into how transportation management can be done on a day-to-day, shift-to-shift, hour-to-hour basis. This is another view of what we're going to show today. At the long-term side, first we need to model the end-to-end supply chain network. Then we'll perform the planning based on the model supply chain, as well as the forecast demands from the sales team. Finally, we will need to do some scenario simulation in order to make a decision. Next, on the day-to-day level, we will go into the logistics plan, where we focus on one particular part of the supply chain in Philadelphia, where as a warehouse management, how do we actually ensure that by utilizing all our resources, how do we pick up and deliver all the orders from different locations to different locations at different time windows. Finally, we'll go into a particular assembly line in the Shanghai factory, where we will look into how the AGV can be planned, utilizing the autonomous vehicles to actually carry components from work center to work center. Let's go to the demo. This is the digitalized supply chain that we have modeled in the system. So, as you can see, this whole exhibition is about the gearbox factory, and this is the supply chain that spans over the whole 4 continents. But for today's case, we will focus into the Asia factory. As you can see here, we have a Shanghai-based factory here with their suppliers, as well as the transportation capacity model. And if we drill further down, and in this particular factory that is producing gearbox, we can see there are 3 assembly lines here, then followed by a testing line before the finished goods is stored at the warehouse. So after we model the digital, let's say the supply chain into the system, it is then the next step about deriving value from the supply chain. What you see here is a plan, let's say for the next 12 months, that after collecting the sales forecast from the sales team, and after, let's say, based on the capabilities of our supply chain, how much forecast that we can fulfill. So you can see here, for example, we have all the resources model here. Each of these period actually represents, each of these box actually represents a week or 7 days of capacity. And you can see with different color code, if it's green color, that means it has excess capacity. If it's yellow color, it means that it is almost fully utilized. And on the right side, you can see some KPIs, including the operational KPIs as well as some financial KPIs. So at a glance, based on the capability that we have in the supply chain, it shows that we are able to fulfill 94% of our fulfillment. In other words, there are 6% of our customers that are still not so happy. That's based on the forecast. And here you can see per sales segment, per customers, who will be the customers that will be all fulfilled, and those 2 will be partially fulfilled. This, let's say on the top part of the KPI dashboard, it also shows that those are the financial KPIs that are associated with the result of the plan. So at 94% fulfillment, the margin is about 650 million. This is the existing plan. Now, as the management, very likely or very often questions will be asked. Is this the right plan? Can we actually do better? Well, to understand whether we can do better, if we can do better, we first need to understand where we can get those additional 6%. So we will do this by analyzing the bottleneck resources at the Asia level. So at a glance, you can see at the Asia level, the assembly line 1, 2, and 3, they are fully utilized. So this means very likely the missing 6% of the forecast does come from the, let's say currently bottleneck resources from the 3 assembly lines. Now to understand if we are able to do better, it means answering the question, are we able to increase capacity for the assembly line? Increasing capacity can mean increasing or adding another production line, but also at the short term, are we able to actually increase the capacity by changing the shift pattern? To understand this, we will need to do a scenario simulation. So a scenario simulation can be done by just copy the existing base scenario. So a lot of times, these kind of questions, this kind of planning are done currently using a very manual way. And when things get updated or things get changed, a lot of times planners do struggle to get the information updated to refresh for the new simulation. But with a digitalized supply chain into the system, this simulation can be done by just a single click. And now you can see the what-if scenarios here. It's exactly having the same configuration as the base scenario. And what we're trying to do then is trying to see if it's possible for us to increase our capacity in the 3 lines. Here you can see all these 3 lines are fully utilized for every single week. However, you can also see some gray area here, which represents the non-working days within a week. We will try to increase the capacity by changing the working shift pattern from 5 days, 24 hours a week to 7 days, 24 hours a week. Now, with this change, immediately you can see there will be some additional capacity available, but also you have seen, probably you have noticed a slight increase in the fixed cost. That is caused by the additional working hours. In order to maximize the fulfillment, we're going to do the same for assembly line 2. Now, with this new scenario, we will need to find out how much more can we do in terms of fulfillment. So to do that, we'll rerun, let's say, the optimizer. There are many different ways of, creating a plan. So of course, we can creating a plan. In this case, our default strategy would be to ask the optimizer to focus on the margin. But it can also be that, let's say, have a different strategy that gives a different weightage to different business goals as per the need of the scenario. But for now, with the new additional capacity, we'll rerun the optimizer using the same capacity. One thing to note here, it is always possible to create a manual plan, and very likely planners will start by creating a manual plan. But with the whole digitalized supply chain end-to-end, it may be, let's say, humanly or manually difficult to do that, then therefore the value of optimization is here. With the optimized scenario now, you can see all of them, they are fully loaded, and you can see the fulfillment has increased from 94% to 99%. But is this the right plan? To understand this, we'll need to do a scenario comparison. Here, you can see both the base scenario and the new what-if scenario created side by side, and their respective KPIs being recorded here. While you can see there will be an increase in the fulfillment, what you can also see, there is a drop in the margin. And in this scenario, it is likely because, let's say, the additional costs in the operations actually causing the dip, causing the drop in the margin. While what we see here is, on one hand, you have a base scenario that focuses on margin, and another scenario that focuses on customer satisfaction. It is the management decision to decide which scenario would be the preferred working scenario moving forward. But with a system and the right, let's say, with the right level of the supply chain detail model, as well as the right business goals configured, it is possible for the management to make informed, conscious decision as a team. Once this plan is then agreed, this plan will then flow down to the day-to-day planning. where next we'll move to our second demo, where we go into a particular area of our supply chain in Philadelphia to look how we can maximize our delivery on-time performance for the shipments. This is at the midterm level on the day-to-day, week-to-week basis of planning. What we see here is we have a warehouse in Philadelphia, and we have a fleet of trucks and drivers. And the goal here at this level is trying to pick up various parts from various pickup windows and deliver to various factories in different locations at different time, with different quantities and different priorities. So it is important for us to have the right level of details here because let's say in this case, all the trucks with their locations actually recorded. And also this system is actually connected to a jaw informational system where all the coordinates between the two locations and the distance being calculated. In terms of value, in this level of planning, you can see a few KPIs being defined here in the dashboard. So for example, we will need to try to minimize the late shipments. And at the same time, we will also need to minimize the total distance travel because the travel distance means fuel and in other words means, let's say, cost. And also let's say the associated cost will be also displayed in this dashboard. To plan an order or a shipment to a resource, we can simply just drag and drop to a particular truck. You can now see the truck and driver, which is from Manhattan. They need to go to Philadelphia to do the pickup and then travel to Glassboro for delivery before it returns to Manhattan. While this is just a simple sample, the actual business scenario can be much more complex in terms of the volume of the orders to ship, the amount of resources we need to operate, as well as the, let's say, for example, there will be a lot more complexity in terms of logistics. For example, the cross-docking, the multi-loading, multi-unloading. And therefore, let's say by using the right optimizer, you will be able to, let's say, come up with the most optimal result with the given time frame. So the optimizer is now running, considering all the orders and all the resources that we have. You can see the, let's say, first is trying to reduce the reduce the late shipments. But as a result, the total cost and the total travel distance may increase. So this is more of a trade-off. So if you would like to have all the orders delivered on time, very likely you need to utilize much more resources. But on the other hand, if you want to minimize your costs, you will need to use as few resources as possible. So the trade-offs and the weightage between the trade-offs would be something that the optimizer would be able to help you to come up with an optimal plan. You can also see the optimizer is constantly improving itself to try to minimize, let's say, all these three KPIs. And this system also connects to the transport management system, where the actual feedback of the execution will be reflected back to the plan, where based on the actual feedback, the optimizer would then be able to re-optimize and reroute as per necessary. With this, we have concluded our second demo. Next, we will move into the third demo, where we go into a particular assembly line that we have seen in the first demo to see how AGV planning can be done. So this is one snapshot of the shop floor. So you have all the work centers here, ABC, all together 9 work centers. At the operational side, it is required to carry components from work center to work center. And this is done fully automatically by the AGVs or autonomous vehicles. And here you have seen 3 charging stations because AGV, it's let's say as powered by battery, it is necessary for the AGV to recharge after traveling for 1,000 meters. Here you see all the orders, let's say the RE40, which we have seen on the other side on how this can be produced. Or they have a small size variant, medium size variant, and a large size variant. In this part of the factory, we have 3 AGVs, 2 small AGVs and 1 large AGV. To carry a small component, we will need a small AGV. To carry a medium-sized component, we will need a large AGV. And to carry a large component, we will need a combination of two small AGVs to operate. And when the AGV is traveling on one side, it is not allowed for the other AGVs to travel in the reverse direction. Now let's see how this planning can be done. So planning can be done by just dragging and dropping an order to the small AGV. So here you can see, let's say this is from A to C. So for example, let's say this is charging from A1 and travel back to C. At the moment, this has a problem, as this movement actually requires two small AGVs. So we're going to solve this problem by dragging it to another AGV. So now you can see this is now, this problem is now gone. And let's plan more of the orders. You can see the pink line here indicates the earlier start time. So at this operational level, it's down to the minutes and sometimes seconds accuracy. It is important for the planners to have all the right information shown on the screen to be able to make a conscious and right decision. Now, if we want to plan the medium size of the components, we need to plan it on the large AGV. And we're going to continue to plan a few more. So, after planning for 4 orders, suddenly we have another problem. Here you can see there is an out of battery sign here that indicates the RGV actually requires a recharge. However, if we only recharge it towards the end of the movement, it is not possible for the AGV to be able to reach the recharging station. Therefore, it is necessary to actually recharge at the front part. So with the recharge, it is then able to, let's say, continue the delivery and making sure all the orders are delivered on time. Now, again, let's say in the actual world, where you have much more work centers and much more shipments to make, having to do a manual planning, it's one way, but maybe not the most optimal way. And again, this is where optimization with the right KPI weightage would bring values. We can see now all the orders are planned with the minimum, let's say, lateness, and therefore, let's say, helping the business to actually anticipate the kind of orders delivery that will be taken place. As a summary, so we have seen how planning can be done in the long-term, mid-term, and short-term level to extract business value from a digitalized supply chain. And in real business, you can see how, let's say, how simple those demos are, and how complex it can be in the real business. And therefore, in the much more complex operation, optimization will help you to extract the right value in your business. So we have seen in the last 3 demonstrations how a digitalized supply chain can be utilized to create business values supported by optimization in long-term, mid-term, and short-term level. While these 3 demonstrations are relatively simple, you will realize operations are becoming more and more complex every single day. And with increased level of complexity, it is therefore more and more difficult and challenging for planning to be done in a traditional and manual way. And therefore, digitalized supply chain supported by the state-of-the-art optimization technology will be important for your day-to-day business. Thank you.